How do you measure the mass of objects in microgravity?
Well, we have a system here over, and it's located, unfortunately, down in one of the other modules, so I can't show you, but I can show you the basic idea here. The way it works is it uses a property of the fact that when you push on something with a certain force, it'll start to accelerate, it'll start to move. But the heavier, or the more mass it is, not necessarily the heavier it is, but the more mass it has, the slower it accelerates. So if something is twice as massive, it will only accelerate half as much if you push on it with the same amount of force. And that means that, for instance, if you have a spring pulling on, you can measure how fast it starts to move, and using that, figure out what its mass is. And I got a little demonstration here. Actually, it uses something, a little slightly different concept, but let me first show you one thing here. And this is just a tape measure, a plain old ordinary tape measure like you might find in a hardware store. And it retracts automatically. Basically a little spring. But what I can do is show you that if I attach this to something and then release it, the greater the mass is connected to this, the slower it accelerates. Let me show you. What I've done is just tape the tape measure off to this panel over here. I'm gonna pick my feet up and let this thing go, and I'll show you how fast it pulls me towards the wall here. So you can see it's fairly slow because the spring is not very strong. So now what let me do is I'm going to lock this thing off, and I'm going to attach to it something which has much less mass than me. This is just a roll of gray tape. You can see that accelerated much faster, and the reason is because it's much less massive than me. You can use that principle to measure the mass of objects. Now, what we do actually over in the with our measurement device, we use basically the same principle, but there's a little more accurate way to measure it, and that basically makes use of the fact that if you have a spring pulling on something, it's going to pull on something just like this tape measure did. But what it will do is if your spring has a center point, it will actually go past the point and swing back and oscillate back and forth. And so what I've done here is I've set up a little demonstration. I've strung a bungee across the corridor here, and it's basically something like a spring. If you pull on it, it bounces back. And what I'm going to do is pull on it, and I'll show you that, and then let go with my feet, and I will move back and forth, and you can see that I'll move back and forth at a certain speed. Now, if I put a lighter object on there, the spring pulls it quicker when you let go of it, and then quicker when it pulls back the other direction, so it actually will oscillate back and forth at a much higher speed. And the speed at which something goes back and forth for the same size spring, if you put different masses on it, is going to depend upon the mass of the object that you put on it. And that's something that the students can try at home. You can set up a small small device in a box with a couple of springs and different masses, and you can show that this works. So let me show you here. You should have been able to see that I was moving back and forth, and it took about maybe 2 seconds to go to one end and back. what I've got here is a big wrench, but it may be a big wrench, but it certainly has much less mass than me. And let me attach this to the same thing, and we'll let go of it. And we'll watch how fast it moves back and forth. You see this is moving quite a bit faster. It probably took maybe maybe a quarter of a second, something like that, to go from one end and back and forth again. So, in fact, the apparatus that we have is a much better version of this. It is a finely calibrated spring, and it measures the frequency or the period, the amount of time it takes to go back and forth, very accurately. And from that, we measure our mass.